Today we are going to be following the journey that electricity takes from its creation in the power plant to how it's used in your home, how it gets to your home first, of course, and then how you can save energy inside your home. First thing you need to know is the concept of how you actually can make electricity, which you can do yourself as an experiment. You need a coil, a rather long bit of insulated wire. It has to be insulated, we learned the hard way, or otherwise it short circuits. Wrapped around approximately 400 times. And then you have to find a way to turn a magnet quite quickly in this coil. Attach the other side of the coil of wire to, let's say if you wanted to light up a flashlight light bulb. That would be approximately how much energy you'd need to do it. So that's basically the same thing as they do in a power plant. Except instead of turning a magnet manually or with a mechanism, it would be using some natural resource. Now, in my example, you would need a hydroelectric and probably a dam. So the water would be coming down here, and this part is called the turbine. So spinning the turbine. Now, the turbine is always attached to this shaft. So when the turbine spins, the shaft spins. Now, since the shaft is connected to a magnet and the shaft is connected to a magnet turning inside of a generator, and inside a generator, you guessed it, there's going to be about 4 million coils of wire instead, because it takes a lot more energy to power a city than a little flashlight light bulb. Now, when it's traveling out of this power plant, it doesn't just flow through. Instead, every electron jumps from atom to atom. So it's a little different, and the atoms don't move. Like in this example, it's sort of the same because this yellow marble goes through one side, and out comes a black marble, and its tube is full of marbles. So it's sort of the same because this marble, the yellow marble, does not come out of the other side. Instead, the black one does. So it will take quite some time till the yellow marble comes out the other side. So now we have the electricity traveling out of this wire at approximately 24,000 volts, till of course it comes to this transformer. This is a step-up transformer, and transformers' main purpose is to change the number of volts that the electricity is traveling at to a different number. So it's taking 24,000 volts, and it's going to change it to 345,000 volts, because the higher the volts, the faster the electricity goes. So basically, inside of this transformer, there's going to be an iron core. And forget this for a second and just see, if you were to have 10 volts and you wanted to have 100 volts afterward, what you would have is you would have 10 volts, and wrapped around one side of the iron core you need insulated wire, remember, to be wrapped around approximately, well, of course, just exactly 10 times. And on the other side, then you would have to have it wrapped around 100 times to increase it times 10. So basically it's traveling through this coil of wire, and then it travels through the iron core. And since it's wrapped around many, many more times, it steps up, as a transformer is called, the voltage. So now after going in this transformer, it's traveling out at 345,000 volts, until of course there'll be more than one steel transformer tower. It comes to a steel transmission tower. So basically the purpose of a steel transmission tower is for it to keep the wires from touching the ground. It's quite simple. Now, it comes to another transformer, and it's a little different. It has the same concept, iron core and coils of wire, except it is called a step-down transformer instead of a step-up transformer. So basically, if you were to have 100 volts and you wanted 10, and wrapped around an iron core, you'd have to wrap around one side of it 100 times, and then the other side would be just 10. Same concept, except it's backwards. So now, after it being 345,000 volts, it's going to be brought down to 13,800 volts for use in warehouses and large businesses, factories as well. As with this example, Puffin Pulp Paper Mill Co. So after it's been used in large businesses, warehouses, and factories, it's going to be traveling out of the wire still at 13,800 volts till it's going to come to one of these poles. Now, you'll see the poles everywhere all over the city, on the sidewalks mainly, and there'll be lots of them, except they're all a little different, consisting of the different kind of wires that are attached to them. And some of them have a rather smaller transformer. So it's the same concept. It's still a step-down transformer, except it's much smaller, so it can fit on this pole. So now that takes 13,800 volts, same concept, and step down to 220 or 110, depending on the size of the house. So we're going to say, since this house is rather small, that it's going to run on 110 volts. So, and it takes 11 volts to, if you had a motor for this toy train, to run this toy train. So you can make your own transformer if you had an iron core with 110, with this wrapped around 110 times, and on the other side 11 times, and you could power your own little toy train. So now, all over your house, everywhere, there are things. There's lights, microwaves, refrigerators. There's so many things that are powered by electricity, and as well as phones. So, if you were to dissect a phone, what you would find inside is, just where you see this mouthpiece, behind that would be a little microphone and a diaphragm. So when you speak, it would vibrate the diaphragm, and the microphone would pick up the sound waves and turn them into electrical energy. So then it travels through all sorts of wires till it gets to the other person's phone, and it comes to something like this. So what happens is now the diaphragm is going to change the electrical energy into sound energy, and is going to vibrate this diaphragm once again. And that, of course, is what makes your phone work. So you can actually hear the sound coming out of this side. So that's how you can talk on the phone to your friends, your parents, and all sorts. Just a sec. Hello? Okay. Alright, bye. And telephones work. So now, it's not just about how electricity can be brought from, for example, if it was hydroelectric energy plant, all the way to your home and how you can use it there. There's more than one way to generate electricity. Even if hydro is the most popular way of generating it in BC, there are many other ways, as you see in Green Electricity Resources of British Columbia. But even though hydro is 87% of how we generate our electricity, natural gas consists of 10% of the electricity that we generate. It, however, is not on here because it is not environmentally friendly, because it produces CO2, greenhouse gases, and all that sorts of things that are not good. So then, for the other 3%, there's all the other ways that you're going to see consist of the 3% together. So first of all, it's a little different than hydro. It's small hydro. See, for hydroelectricity, you use dams, as in my example. But for small hydro, they use rivers instead. So there's no flooding. However, even though it seems to be a really good way of generating electricity, and it seems to work, it is quite expensive, and you cannot generate electricity with it all year round. But there are many other ways of generating electricity as well. For instance, one that's quite different is biomass. So biomass is good because it takes the wastes from the forestry industry and doesn't produce much waste itself. However, it's not very strong, and it's still being experimented with now, so we're not quite sure about that one yet. Another different one as well is wind. Now, wind doesn't have much pollution, of course, or hardly any at all. But, however, as you must know, wind is never constant, and is quite expensive to generate. One that we should all know by now is solar energy. Now this, as we all know, is quite, environmentally friendly. And it can be built into homes, and the excess electricity that I have can be sent to the main grid, and people can buy it. However, it is not constant, because not every day it has sun coming down at full force. There's some day when there are many clouds and there's not much sun, and then you might go a day without any electricity at all. Of course, one that you might not know what it is geothermal. Geothermal takes the heat from the ground and makes it into electricity. It is inexpensive to run, but you probably guessed it, it's very expensive to build. One that's quite different but uses the natural resources is ocean wave. Now, ocean waves are predictable because we can predict when the waves are going to become at full force, but it's quite hard to access, and it's not very strong, so it's not probably the way of generating electricity of choice. And that's quite a bit similar is tidal current. Now, it is predictable, just like ocean wave, but it's not very environmentally friendly because it blocks where fishes could go, and where fish could go. And it also blocks boats if there's not a lot of room around where they're using the tidal current. Also, it's not very constant, so it's not a very strong one either. So there's many different ways of generating electricity, and of course there's many ways of using electricity, and there's many ways of helping to save electricity as well. So as you see here with the 1 ton challenge, they've got tons and tons and tons of ideas of how you can save energy without really, paying thousands of dollars to make your house run by solar energy, or changing all of BC's ways of generating electricity. It's just little things that you can do inside your house that can actually help with saving energy. So there's lots of different ways to do it. It's a quite fun little booklet because there's lots of information, and there's also lots of pictures. So you might want to have a look at this. You can get them in lots of different places. For instance, it has things like this if you want me to read something to you. I think I lost it. Anyhow, it's really cool. If I remember properly, if everybody in Canada changed just one of their normal light bulbs into more energy efficient light bulbs, we'd be saving about approximately the same amount of 66 million cars, or 66,000 cars. So just by changing one light bulb in your home, you could have a drastic effect, but a good drastic effect on the environment. So it's things like that, and you can pick up your own 1 ton challenge booklet in lots of different places. Anyhow, thank you for following the journey that electricity takes from the power plant and its creation all the way to your home, different ways of generating electricity, different ways of saving electricity, as well as looking inside a phone. And oh, there is one more thing. When you're looking inside a phone, you can also look inside a battery if you hacksaw it open. Now, there is one thing that people get confused with a lot. See, the difference they don't know is in between electricity coming from a power plant and a battery. It's a little bit different because a battery uses a chemical reaction to generate electricity, not a natural resource. And it's quite efficient if it's something smaller, but you would not want to use a battery to run all your lights and your refrigerator and your microwave or phones, for example, because they can get dead as well. But they're great for things like flashlights and alarm clocks and cameras. So this is what it looks like inside, and when it's not hacksaw open. So thank you for journeying with electricity with me. Bye.
Do you gotta stop it first? It's spinning. Feels like it's spinning. Do you gotta go turn it off?